Welcome back. It is 8:32. This weekend, NASA is set to launch its latest orbital observatory, the Nancy Grace Roman Space Telescope, to discover new galaxies and understand the nature of dark energy. Interesting. Joining us this morning is Dr. Sangeeta Malhotra, the NASA's Roman research astrophysicist. Good morning. Thank you so much for being here. We appreciate your time this morning. First off, I think we need to ask the question that I think everybody is wondering after that intro. What is dark energy and how are you guys using this telescope to look for it?
So dark energy is this mysterious force that's making the expansion of the universe go faster than we had accounted for. And we've known that for quite a few years, and that the expansion of the universe is not only not slowing down, it's going faster, it's accelerating. And the question is, what's doing it? And whatever is doing it, we call it dark energy. We know the effect of that thing, and we are trying to quantify it even better and see how that effect changes with time. So it's like we won't be observing dark energy. We'll be looking at galaxies and mapping them out. But it's like the wind. You never see the wind, but you see the effect it has on moving trees about and all that. So galaxies are our trees, and dark energy is our wind.
Interesting. So we're looking to see how this dark energy is impacting the things in our universe. That's very cool.
That's so interesting. What is it that you'll be looking for when you're mapping out these galaxies and star clusters, everything that you're seeing with this telescope, to be able to actually tell, okay, why is dark energy doing this? Why is the universe expanding faster?
Yeah. So we'd be doing it with 3 different methods, but one of the methods is to map out in 3 dimensions how the universe, the web of the universe looks like, of galaxies. And remember, each galaxy is like our Milky Way, about 100 billion stars. So, but for this purpose, we just say a galaxy is 1 unit. And gravity pulls them together, makes them cluster, and dark energy is making the space expand. So looking at their distribution, we can say from this time to this time, the acceleration has gone like this. The expansion has gone up or not. The second method is to use something called supernovae. These are stars that explode at the end of their lifetimes. And they're rather pretty standard in their brightness. So we'd be looking at them back in time to see how the expansion of the universe was proceeding as we go back in time. And the supernovae were the most convincing thing that alerted us that the expansion of the universe is expanding. And the third method is to use the slight curvature of galaxies as light is bent by matter to get a sense of dark matter.
Interesting. Well, let's talk about the orbit that this telescope will be in, because it's got to be very specific so you guys can kind of detect what you are looking for. Talk about the orbit. How are you guys going to be positioning this telescope?
So this telescope is going to what is called the Lagrange point 2. It's beyond the moon, and it nearly where JWST will be, but not too close. And what that does is it gives us very precise cooling, and we can keep the detectors at a good temperature, and the Earth doesn't light up the sky half the time. So it's a very stable environment in terms of cooling and the detector performance. And we can use all of the time to observe. Sorry, go on.
Very interesting. How does this telescope compare to other ones like the James Webb or the Hubble telescopes?
Yeah, so the Hubble was the original, and we learned a lot from it, how to do instruments and things like that. It also goes to the very blue, to even bluer than we can see with human eyes, to ultraviolet. The birds can see ultraviolet, we can't. JWST, the Webb, has huge light gathering power. It has big mirrors, and it can see to cosmic dawn, very far away, very, very sensitive, but it has a smaller field of view. Roman has a field of view that's about 100 times the field of view of either Webb or Hubble, roughly. But in terms of scanning the sky, it's 1,000 times more efficient because we worked at the stability and how fast, you move from one, you point at one place and then to move to the next and the next. And that is optimized to go very fast. So this one is designed from the start to take huge swaths of sky, take images of those.
Very interesting. So this telescope has a unique name. Of course, we have James Webb, we have the Hubble telescope. This one is the Nancy Grace Roman telescope. You hear Nancy Grace and you can't help but think about the true crime journalist, right, Nancy Grace. Is that who we're talking about here? Is there another maybe Nancy Grace that might be the namesake for this telescope?
So Nancy Grace was the first chief astrophysicist. She joined NASA in 60s, and she enabled all of these space telescopes that have gone above the Earth's atmosphere and done great science. So sometimes she's called the mother of Hubble. So we've finally been able to name something after her.
That's so
Yeah, very
amazing.
cool.
Yeah, how can people watch the launch that's going to be happening, and when will that be?
So the launch is expected to be on Sunday morning if the weather and things cooperate. Not before 7:25 Eastern time in the morning.
Okay, so you got to be up really early to watch that lift off if you want to see that. When will we be able to see the first images from the telescope?
We expect that to be sometime in January, but before that, a lot has to happen. The telescope launches, and then the deployable things deploy, they open up, the instruments cool, it gets to where it needs to go to L2. That takes 3 months, and while it's doing that, we align the telescope and they align the instruments, calibrate them, check out a whole bunch of, we have this whole sequence of checking out things, and that's called commissioning. So we are all going to be very, very busy.
Yeah, it sounds like it. Well, Dr. Malhotra, we really do wish you guys luck on this launch, and
Thank you.
We're really excited to see what comes out of this new space telescope. Thank you so much for your time this morning.
Thank you. We are very excited too. Thank you.